Hello my dear students, welcome back to Learn Physics. In today's video, we are continuing with the kinematics portion. Last class we learned about the acceleration, velocity and time, how to find out. Right? So acceleration to find out, from displacement to find out the velocity, we can differentiate the equation, and from velocity to find out the acceleration, we can differentiate, and for integration, for converting from acceleration to velocity or velocity to distance, we can integrate the equation. So relating to that, some numericals we are going to do now. So first question, displacement time equation of a particle moving along x-axis is displacement time equation. X is equal to 20 plus t cube minus 12t. Find the position and velocity of the particle at, we should find out the position and velocity of the particle at time t equals 0. And second one, state whether the motion is uniformly accelerated or not, and we should find out the position and position of the particle when velocity equals 0. So these are the things which we need to find out. The second one is whether it is uniformly accelerated, uniform acceleration or not. This is what we should understand. First one, position and velocity when t equals 0. You can easily find out the position of the particle. X is equal to, you can substitute t as 0, then x you will get it as 20. How to find out the velocity? Velocity we know that we should differentiate the position. Then we will get the velocity. For that, d by dt of 20 plus t cube minus 12t. So differentiation of a constant is equal to 0. Differentiation of t cube is 3t square minus 12. So substituting when t equals 0, then we will get it as minus 12 meter per second. Okay, then whether this is uniform acceleration or not. Velocity, whether it is changing with respect to time, v is equal to 3t square minus 12 we got. So it's a term which is depending on time. So velocity is continuously changing with respect to time. Therefore, it can, and 3t square minus 12. So while that's looking at this equation, whether it is under it's a straight line motion or parabolic motion, here we will get it as it's a parabola. Okay, parabolic motion. So when we can say it is not uniformly accelerated. Not uniformly accelerated. So if it is uniformly accelerated means we will be getting a straight line equation. Y is equal to mx plus c. In that way we will be getting an equation. This is the equation in terms of 3t square minus 12. So this is the equation of parabola. So we will be getting a parabolic equation. It's not coming under uniform acceleration. Then the third one, find x when v equals 0. So when v equals 0, then 3t square equals 0 equals 3t square minus 12. So t square equals 4, t equals 2. So what will be the position when t equals 2? X is equal to 20 plus 8 minus 24. So here we will get it as 4 meter. Next is velocity time equation of a particle moving in a straight line as v equals 10 plus 2t plus 3t square. It's given, it's in SI unit. Find the displacement of the particle from the mean position at time t equals 1 second. We need to find out the displacement when t equals 1 second. If it is given that displacement is 20 meter. So displacement equals 20 meter at time t equals 0. Acceleration, second one, acceleration time equation. So here we need to find out x when t equals, displacement is it's 1 second. When t equals 1 second, find the displacement. For that, first it's given for velocity as 10 plus 2t plus 3t square. To find the displacement, we should integrate it. Integral x is equal to integral dv by dt. So while integrating, we will get it as 10t, integration of a constant. So if you know the integration, in the last class I told you integral x to the power n is equal to x to the power n plus 1. Or if limits are there, we can apply that also. Here it is given simply 10. 10, we can write it as 10 into t to the power 0. That is 10 t to the power 0 plus 1 divided by 1. So you will get it as 10t. Okay, so this is how we should, at a stretch maybe you won't be getting, but when you are doing so many numericals related to the display, integration, you will be easily find out you can easily find out the integration. Okay, so if you are in 11th, maybe you will feel a little bit difficult for doing this integration part, but when you are going to the 12th, will be easy, because there you will be learning this as a subject. It's in maths itself you are studying the main part, integration and differentiation. Okay, so it has 10t plus 2t square by 2. So here we will get it as t square plus 3t cube by 3. Here it is t cube. So when t equals 1 second, 10 plus 1 plus 1. So here 12 meters. So here the distances, it's in the question, it's given like x is equal to 20 meter at t equals 0. This is the displacement at 1 second, right? That is 12 meter. So already at t equals 0 second, displacement is 20 meters it happened. So what will be the net displacement? Displacement will be equal to 20 plus 12, that is 32 meters. This will be the total displacement. Or the same thing, how you can find out at a stretch. So here, instead of doing in such a manner, you can write like velocity is given like this. So instead of velocity in terms of displacement, I can write it as dx by dt. That will be equal to 10 plus 2t plus 3t square. So here dx equals 10 plus 2t plus 3t square dt. Now differentiate both the sides. Time is changing from 0 to 1 second. Displacement is 20 to some distance. We don't know that value, right? So here integral 20 to x, we don't know what is the value at 1 second, right? 20 to x, dx will be equal to integral 10 plus 2t plus 3t square dt. What is the time which is changing over here? At 20 it is 0, it's 1 second. What will be? We need to find out. So integral dx is x, and applying the upper limit minus lower limit x minus 20 equals 10t plus 2t square by 2, that is t square, plus 3t cube divided by 3, that is equal to t cube, 0 to 1. First we will be applying the upper limit over here. So 10 plus 1 minus 0 we will get. So here it is 12. Therefore x will be 20 plus 12, that is equal to 32 meters you will get. Clear, children, how to find out? So at a stretch, without thinking this much, you will be directly getting the answer. So we can apply the integration part over here. Next is, what is the displacement acceleration, uniform acceleration time equation? For that, velocity already given. To find out the acceleration, what can we do? To find out the acceleration equals dv by dt. So differentiate this equation. Differentiating 10t plus 2t square by 2, 10 differentiating the constant. This is integration. So d by dt of 10 plus 2t plus 3t square. Differentiation equation is d by dt of x to the power n is n into x to the power n minus 1. So here differentiation of a constant is equal to 0. So this is 2 plus, here it is 60. A equals 60 plus 2. This is the acceleration time equation. Clear? Now I'll give you two questions for homework. That the velocity of a particle moving along x-axis varies with the time as v equals 10 plus 5t minus t square. At time t equals 0, x is equal to 0. Find the acceleration at time t equals 2 seconds. X coordinate of the particle at time t equals 3 seconds. So it's easy. You can acceleration means here it is velocity is given. To find out the acceleration you should differentiate, and to find out the displacement you should do the integration. Okay, velocity to displacement integration you can do. A particle is moving with a velocity v equals 3 plus 60 plus 9 t square centimeter per second. Find the acceleration at time t equals 3 seconds. What you will do? Just differentiate the velocity. You will get the acceleration. You can substitute at t as 3 seconds. Displacement of the particle in the interval t equals 5 seconds to 8 seconds. What you will do? Differentiate the displacement. Velocity is given. To find out the displacement, you can integrate in time limit 5 to 8. Integral 5 to 8. First, v equals 3 plus 60 plus 9 t square. Integrate that, and in the limit of integration, you can give t as 5 and t as upper limit as 8. Try to do that. So next question is, x coordinate of a particle moving along the x-axis is x is equal to 2 plus t square plus 2t cube. Okay, here x is in meters and t is in second. Find the position of the particle from where it started its journey. So find the first one as we need to find out the position of the particle. Initial velocity of the particle. So here you should find out initial velocity and find the acceleration of the particle at t equals, when t equals 2 seconds. Okay, position you need to, when it is at the starting of the observation means here first question is when t equals 0. What will be the position? It's 2. Unit is not given, so it's unit if it is meter per second or meter, it's not given, right? It is position. X is equal to 2 plus t square plus 2t cube. If it is whatever unit it will be, it is varying in such a manner. So when it is starting its position, we can say that t equals 0. Therefore displacement we got it as 2. Find the position of particle from where it started its journey. Next is initial velocity. Initial velocity means first we can find out velocity of the particle. Velocity equals 2t square plus t cube means 3t square. Therefore 6t square. Okay, initial velocity. Initial velocity means when time t equals 0. Therefore you will be equal to 0 at that time. And acceleration of the particle. Acceleration, how you can find out? Acceleration equals 2t. Acceleration is 2. Then 6t square 12t you will be getting. Therefore at t equals 2 seconds. Acceleration when t equals 2 seconds, we will be getting it as 12 into 2. It is 24 units. Okay, meter per second square or a centimeter per second square, whatever, you will be getting the answer. So here it is x is in meters and time in t seconds it is given. So we can write it as meter per second square. Okay, next is the velocity of a particle moving in a straight line is directly proportional to 3/4 the power of time elapsed. The velocity of a particle moving in a straight line is directly proportional to 3/4 power of time elapsed. How does the displacement and acceleration depend on time? So here velocity of the particle is moving in a straight line is directly proportional to the 3/4 power of time elapsed. So velocity is directly proportional to t to the power 3/4. Then how can we find out the displacement and acceleration? To find out the acceleration, dv by dt. Therefore, which we will be getting it as 3 by 4 t to the power 3 by 4 minus 1. So here 3 by 4 t to the power minus 1 by 4. Then displacement we can find that integral dv. Therefore, integral t to the power 3 by 4 into integral t by 4 is t to the power 3 by 4 plus 1 divided by 3 by 4 plus 1. So here t to the power 7 by 4 divided by 4 by 7. So here we can write it as acceleration is directly proportional to t to the power minus 1 by 4. Displacement is directly proportional to t to the power 7 by 4. So it will be varying in such a manner. So these kind of questions are easy questions, but there when all the questions at test when it is coming, you should identify that we should do integration or differentiation. For that you should do more numericals, and today's homework questions also I think it will be easy for you, and please try to solve it. So I am winding you for today, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.